Hello and welcome back to Physical Geology. I'm continuing here with the Minerals Lab, and in this part we're doing the next activity, which deals with how the mineral breaks or how it cleaves and cleavage. And it's really because the crystalline property of minerals, it has this lattice structure, this repetitive arrangement of atoms, and if the atoms are arranged in rows or columns, that geometry will be reflected in weak zones or patterns where the mineral will prefer to break, and that's what we call cleavage directions. For example, galena, you can see that it forms these nice 90-degree angles, and you can sort of see, I always think of these steps. If you're looking at this front face here, a step from here, step down to there, so, and you can see that they're all parallel directions because that's the way the atoms are arranged within the crystal structure. So think of these cleavage directions as really an expression of weak zones or directions in the lattice or crystalline structure of the mineral. And when we look at cleavage, and I've been pointing this out with luster especially, we see this strong reflection of light. Minerals with really brilliant or bright luster are usually the minerals that have very good cleavage. When we're looking at cleavage, you'll see the light reflecting here off of a planar surface, but here you can see there's many different steps, as I was pointing out over here in the galena, and again the light's reflecting off the different steps, but they're all reflecting at the same angle, so you'll see that flash across the entire surface. That would be good cleavage. Where the cleavage is poor, you can see that you will not get a clear enough or bright reflection. So that's telling us there's poor cleavage. And if the mineral has no cleavage at all, has a fracture, you would see this random direction of light bouncing off into direction. So you wouldn't see that flat parallel direction or repetitive direction you would expect to find in cleavage. Quartz is an important mineral. Quartz has no cleavage. Milky Quartz has this fracture called an uneven fracture. Pyrite also has no cleavage, and pyrite usually breaks in these hackled regions, or called Hackley fracture, which is sort of something like this, right? You can see there could be splintery and fibrous. But then the other one, this conchoidal fracture, is common to the clear crystals of quartz. And that's kind of how glass breaks in this curvy fracture. You can sort of see those curves, and that's what we call conchoidal fracture. You'll see we'll be looking at Milky Quartz, and Milky Quartz has these partings which sort of look like cleavage, but you'll see that the partings are not parallel. And I'll try to point that out on some of the minerals. I want you to try to describe cleavage in terms of a pattern, whether it's no cleavage like quartz, or if there's a basal cleavage, one direction. That'd be typical of the micas here. Or a prismatic cleavage like the feldspars, prismatic, two directions here, close to 90 degrees, or two directions that are not 90 degrees over here. That'd be the prismatic, not at 90, and that'd be the amphiboles or the hornblendes. So we got basal, prismatic, two different types of prismatic, not at 90, here close to 90. Cubic is important. Cubic, now think of a box. We have three directions. They all intersect at 90. And that's very typical of galena and halite. That's what we had up over here. This galena is a good example of cubic cleavage. Three directions all around 90 degrees. The other three directions of cleavage is the rhombohedral, or the rhombus. And here we have the three directions that they're intersecting not at 90 degrees. And that's very typical of calcite. So a good way to distinguish between calcite and halite, because they're close to the same hardness, is that calcite will have this rhombohedral cleavage, halite will have the cubic cleavage. That's a telltale sign. Obviously, the other way to do it is by licking the halite, and that should give you a salty taste if you want to lick the mineral. There's also octahedral, and we will be seeing some octahedral cleavage where we have four directions of cleavage. That's very typical of the mineral fluorite. And I'll try to give you some of these numbers, and I'll show you how we're going to measure those. Now for this activity, we have these samples, G, H, I, J, K, and L. And we're going to try to describe their cleavage as whether it's basal, cubic, prismatic, rhombohedral, octahedral, or maybe no cleavage at all, whether it's at Hackley, uneven fracture, or a conchoidal fracture. So let's take a look at the minerals here. The first mineral we want to look at is mineral G. And this mineral G, the first thing I want you to note is that it's very square, and it looks like the edges are all around 90 degrees. And if I look at the corner of a box, like this little corner right here, I see 1, 2, 3 directions of cleavage. And they appear to be at 90 degrees. So I have this little goniometer here, and we'll try to do this, see if it's a cubic cleavage. And when I measure it here, you can see it fits right in between there. So it is a cubic cleavage. And other things I want to point out here is this, you can see the steps going down here. That's telling us that there's a parallel direction going flat. And also if I go this way, I see these ledges going down. So there's another direction going across this way. So it's certainly showing me the different directions of cleavage. And if I point out some other features here, note that I see these 90-degree little steps in here. See that little step right in there? If I kind of zoom in a little bit. Yeah, what I want to point out in the mineral here is I see these lines here that are parallel to the edges. That's telling me that's a cleavage direction. You see there's another line right here. So if this mineral were to break or fall, it's going to break along those zones. So this is a good example of a mineral that has 90-degree cleavage in 3 directions. So the next sample here is sample H. And this sample has one excellent cleavage direction. You can see the cleavage flash going through there. So in this mineral, I also see that there are these other fractures that seem to be repetitive going in this direction here. I see a line going through here and then down over here. And then they seem to parallel this broken edge that I have up in here. So it looks like, and then as I go along, I see this other edge coming down this way, this vertical edge. And I see there's some fractures in here that also parallel that vertical edge. And there's even one back in the crystal back over here. So this one also seems to have 3 directions of cleavage, and they do not appear to be at 90 degrees. Do not appear to be at 90 degrees. So you can describe this sample H as having 3 directions. One good direction, this flat one, you see the good cleavage, but the other 2 are not very good. But there are 2 other directions there. The next sample is this sample I, and the first thing I notice about it is coming into these very sharp, almost pyramid-like structure here. And if I use my goniometer on this one, I see that it has about a 71-degree angle right there. Very obvious 71-degree angle there. So it looks like it could be fluorite. And then the other direction is about 109 degrees right there. So it's fitting perfectly there as well. So this is showing about 71, and it's showing 4 different directions of cleavage. So you can see on this surface here, we have these steps that are going down. There's a higher step here, one here, and then these lower. So that means there's the horizontal one there. Then we have this face over here, that's 2. This top face over here, 3. And then there's this back face over here, 4 directions. So there's 3 on the side and the horizontal. So this has 4 directions of cleavage. And typically this mineral fluorite has that pyramid type shape. You can sort of see the triangular or pyramid type shape for sample I. And here's sample J right here. In this sample, you can see right away that it actually has a little bit of iridescence, a little bit of pearly luster to it. And then we see that it's going to have 3 directions of cleavage, but they're not all at 90 degrees. They're kind of at a different angle there. So it's going to have 3 directions, not at 90 degrees. And if we measure this one here, we see that angle there is 105 degrees. And this acute angle here is the 75 degrees. So this is a good example of calcite. So calcite will have those 3 directions of cleavage not at 90 degrees. So your job is to name what type of cleavage this sample J has. Now the next sample is sample K. And sample K is this one here. We see it has some good cleavage direction there. It's 1. And there's another one too. So this one has 2 directions of cleavage. So that one there, you can sort of see the cleavage flash on this surface here. You can see the steps going down as well. Very good example of cleavage and different steps. And then we have this top surface there. And for this, if we measure its angle, so we see this has about a 90-degree cleavage direction. And this is orthoclase feldspar. So your job is to describe this cleavage as two directions of cleavage at about 90 degrees to each other. The last sample here is this sample L. And sample L, you can see, is very flat. Looks like a little thin sheet of paper, but it is a mineral. And this mineral also has a little bit of pearly luster to it as well. A little bit of iridescence. And there's a little bit of iridescence there. This one, when you break this one apart, it does break into these sheets. So you can see these sheets come apart. So it's going to have cleavage in only one direction. And so we only see one cleavage direction. And so your job is to describe whether it's prismatic or basal or octahedral. So in order, you want to finish up this table 7, and then we'll go on to the next topic.